For my NAT Traversal project, I have chosen UDP hole punching technique using a Rendezvous server. In my paper, I have created first of all a simulation using GNS3. In my simulation, there are 3 separate VMs, each running Kali Linux. Then, I did 2 of the VMs behind routers. Therefore, they are set with a private IP address, while the router uses PAT, port address translation, to translate the private IP address into a public IP address, with a port number assigned. The server, on the other hand, is a public IP address. Before beginning the simulation, I made sure that I can ping client A to the server and client B to the server, though client A cannot ping client B because NAT Traversal has not started yet. I have then made 3 different scripts, each running on one of the VMs. If we go to the server, basically, in a nutshell, the script of the server, we are sending a static IP address and port number. Then, we are combining those together, forming a socket, on which we will be listening for 2 times, expecting traffic, first from client A, then from client B, or vice versa. We store the information received from client A, which will basically contain the IP address and port number of that client, into an array. And then, we will send the information of client A to client B, and the information of client B to the client A. Therefore, this is the work being done by the Rendezvous server. If we on the other side go to client B, the work that client B is doing is first of all sending the information to the Rendezvous server, and then it's going into listening mode, expecting the Rendezvous server to send the information of the other client, therefore in this case of client A. When the information is received, the information is stored in a variable, which will be later used to be the destination of our traffic. In this case, from client B, we are sending 10 times hello 1, hello 2, hello 3, etc. to the other client. Therefore, we begin this by first of all running the server. Here the server went into listening mode. Therefore, it's expecting traffic from one of the clients to receive. We run the script of client B. The server receives hello from client B, and it knows that the IP address that client B is using is 20.20.45.2, therefore being a public IP address, and the port number which client B used was 36,114. Client A will basically do the same thing for now. Therefore, if we go to the Rendezvous server, we see another hello from client A. Now, what will the server do? We send the information of client A to client B and vice versa. And client B will begin sending hellos. It can be seen here, 0, 1, 2, 3. The hellos are being sent. If we go to client A, the hellos are being received. Hello number 1, hello number 2, number 3, number 4. You can see the hellos being received. The only difference that client A did was that it is not sending information, but to be able to receive information after the Rendezvous server sent the information of the other client, we send just a hello packet, an empty packet, to the other client to open the port again, because the port after a certain amount of time gets closed. Therefore, in the future it can be a good thing if we can set a timer sending an empty hello to the other client just to keep the port open. The hellos were all received. The server, the Rendezvous server, its work was all done. It had just to hold the IP addresses of both clients and then send them vice versa, and the hellos were received. And that hole punching was done.